All right, so we're now going to talk about consumer choice and talk about the idea that we have as consumers, what is it that we really want? We're going to assume that consumers want to be as happy as possible. We're going to make a simplifying assumption in our model. We're going to assume that we have only two choices of goods. And so I'm going to talk about some of the ways in which we can become happy by the consumption of this two good. Again, you're simplifying the world, say we have two choices and it's this or that. I'm going to talk about the different, what we call functional forms of, I'm going to call the utility function. Okay, so what's a utility function? Utility is an idea that we could actually measure the happiness of the consumer. And so the utility function, if I have a U, and it's a function of two goods, X and Y, then there's some way to operate on the quantities of these two goods, X and Y. And when I apply this function in a way, of course, that I assume I can measure the utility, then I'm going to get a number. Bigger numbers means that this particular combination makes me happier. There are going to be different combinations of X and Y that are what we call equivalent in terms of utility. And so I'm going to be indifferent between the two quantities because they make me equally happy. Okay, so I'm going to assume three different type of preferences. Okay, and so I just want to make a note on the model that we're using. The model that we're using, as before, assumes that we have unlimited wants. We want a lot of stuff, but we do not have the resources to actually get every single thing that we want. You could think of time, but for the consumer, they're trying to be as happy as possible, and their resource constraint is the budget constraint. They only have so much income. Okay. So I'm going to talk about three different types of preferences. And again, this is a model, and this is our world where I'm going to assume the two goods that I have to assume our first set of preferences would be perfect substitutes. So what's our perfect substitutes? They are two goods that I will be willing to trade off one for the other. And I'm going to give an example of black ink pens and blue ink pens. And I'm going to represent this, my utility function. It's going to be X plus Y. So I don't care, if you look at that function, I don't care what number of X's I have and what number of Y's I have. I just care about the total number. And so look at my different points, the combinations that I would be indifferent between. Okay, so if my utility equal to 7, I could get that in different combinations. What combinations of X and Y would give me that? X could be equal to 1, in which case Y would be equal to 6. X could be equal to 0, Y would then be equal to 7, or X could be equal to 7 and Y could be equal to 0. All of those points give me exactly the same level of happiness. So I'm going to graph that. So let's my whiteboard here, my little drawing tool. And so how does a graph look? And I'm going to make my utility is equal to 7. Okay, on the X, and my X's are black ink pens, the horizontal axis here, and my Y's blue ink pens. So if I have 7 blue ink pens and 0 black ink pens, it's exactly the same to me as if I have 7 black ink pens and 0 blue ink pens. So in terms of the points, so it's 1 point on that. And so importantly, if I plot all these different points, 1 and 6, 3 and 4, 4 and 3, I will get a straight line. And so a feature of two goods that are perfect substitutes is that I am willing to trade them off at what we call a constant rate. What do I mean? I mean that if I try to figure out the opportunity cost, what is it going to cost me to get more of, say, the good on the x-axis? How much of y do I have to give up? I'm going to constantly be giving up the same amount. And that's a feature of perfect substitutes. That's a particular preference. I'm going to talk about another type of preference now. And that preference is going to be perfect complements. So it's perfect complements. This is going to be the other extreme from perfect substitutes. In order to be happier or to increase my happiness, I would have to I'm going to walk back to the first whiteboard now. If I wanted to increase my happiness, I would have to increase the total number of pens. And so I'm just going to label the utility of 7 to be indifference curve 1. Utility is equal to 7. If I wanted to get utility of 14, what would that look like? 14. So 14 blue ink and 0 black ink pens would give me exactly the same utility as 14 blank ink pens and 0 blue ink pens. And so importantly, the slope here should be, move my little x, slope should be the same. The rate at which I trade off is going to be constant, okay? So how do I get to these utility curves? Well, it depends on how much money I have. So if I have income to buy only 7 blue ink pens, or it's gonna be depending on the price, if the prices of blue ink pens and black ink pens are the same, which in the real world, I think they pretty much are, then the budget line is almost going to coincide. So I need more income to get happier. So income is a constraint on our happiness. Okay, and so this is an interesting model, because one of the things that we often look at, and the goal of macroeconomic policy, is to raise the incomes of people. Okay, but in this model of consumer choice, income is a constraint. It is the limitation to our happiness. And so the way that we try to get happier, one way is, of course, if you could earn more income to be able to consume more goods, or assuming that more is better than less. I will make one qualification that we do assume diminishing marginal utility, which means that we are assuming that at some point, additional units of a particular good will make you, not only give you almost 0 happiness, but sometimes negative happiness. Think about eating too many donuts, for example. Okay, all right, so the other type of preference, let's go back here, is perfect complements. And so let me note what that looks like. So I am going to assume the goods are inputs into a toy. So I like to make toys, cars, and I need toy box cars, and I need, let's say, box cars. And I need a box, and I need 4 wheels. And let's assume these are the only things I need. So to get a utility of 1, which we say is 1 car, I'm going to need the minimum I would need it, the minimum of X or my wheels. Let's say my wheels are Y or Y, okay? And so this is also, this model is a fixed proportion model, or Leontief model. And so let's kind of label this. I have the box. I have my wheels. I'm going to put a couple different points that can give me one utility of one in this case. And 1 X equals 1, and X is my box. Let me actually note that. And Y are my number of wheels. X equals 1. Y equals 4. It's my number of wheels. If X equals 1, and I have, you can say 8 wheels, I still can only make one car. X equals 2, Y equals 4. I still only have enough to make one toy car. Okay, so how do I graph this? These things, all of these things are going to give me, as I should make a different note. So in terms of, I said utility 1, but I actually have to note that it's one set of wheels. Hang on, let's see if I can use my select tool here to edit this. So I have to be careful here. So I do want to get to 1. So it's 4 wheels gives me the same as 1 car, but I want my numbers to be the same. So I apologize for that. All right, so if I have 4 wheels, I need 0.25. If I have anything more than 4 wheels, it's not going to matter. If I have 8 wheels, 0.25 times 8 is going to give me, or a quarter of 8 is going to be 2. But if I only have 1 box, I can't make any more cars. So I'm going to draw what that looks like. So I have 1 box, 4 wheels. If I have 8 wheels and I only have 1 box, I still have the same utility. If I have 2 boxes, but only 4 wheels, I have the same level of utility. And so I'm going to call this indifference curve 1. And so it looks like an L for Linda. I always like that, make those notes. How do I get on a higher utility curve or indifference curve? Say, I need at least 2 boxes to be matched with 8 wheels. And so it's going to be the same story. Once I have 2 boxes, it doesn't matter how many more wheels I have. Can't make any more of these toy box cars. And same thing for the wheels. If I have 8 wheels only, and I have more than 2 boxes, I can't make any more. So I can get on a higher curve only if I have more of both. And this is a fixed proportion model, or what we call perfect complements. Okay, so another type of good like this is the left socks and right socks, right? These are sold in pairs. It's just nobody, as far as I know, I don't see anybody selling individual socks, but maybe there's a market out there. There are the unmatched socks. And so the idea is that when we are looking at consumer choice, we need to know not only what they can afford, but also what their preferences are. I'm going to stop this video now, and then we're going to end up looking at a third type of preference, which is much more normal. Not that goods are perfect substitutes, or not that they're perfect complements, but that you need a variety of goods to be, you need a variety of goods to be happy. So in our 2-choice model, you need both goods, and you do get additional utility from one more of good, even if we hold the other good constant, but that they're not perfect substitutes. And what that means is that the rate at which we trade off the goods, or the slope of the indifference curve, is going to change And this is going to bring about this feature that we don't have in the perfect substitutes diminishing marginal utility, or in the case of these perfect complements utility, indifference curves or utility preferences. In the perfect complements, additional units of one good without increasing the other doesn't increase your utility, possibly could not increase your utility at all. So we're going to look at a different set of preferences, and then we're going to combine it with what the consumer can afford, and the consumer is going to try to be as happy as possible, get on the highest indifference curve possible within the constraints of their budget.